Hello guys, welcome back to Maths on African Motives. We are still on our mathematics for grade 12, working with the functions. So we have got a typical exam question that we are going to consider as part of our revisions. All right, so this was taken from the exam of June 2024 from the Free State province. Okay, so we had question number 5, where we are given 5.1 sketched below is a parabola. So we are given the sketch of the parabola, which is given as f, with the equation f of x is equal to minus into x minus 2 squared plus 1. This presentation that we are given, we are supposed to know the format on its own to say what is this type of the presentation. So this is the turning point form, where we can have our function f of x written in the form a into x minus p squared plus q, where the point PQ represents what? The turning point. So remember the turning point form. So this is what we're given, and the questions 5.1 up to 5.6 for 12 marks. So we want to quickly go through these questions. So as an individual, also make sure that you go through the introductions. All right, make sure that you go through the introductions, understand the properties of a parabola. I've mentioned everything that you need to know according to your syllabus. So we are given the sketch, where we have got the point A and the point C as the x-intercepts, the ones that lie in the x-axis, where we do understand y is equal to 0 and this x is equal to 0. And there is also the line of symmetry, which is being given, which is passing through the point B. So thus at the point B, we are referring to what? The maximum turning point, as we have got our graph. All right, for the sake of just revision, let's just say turning point. Yes, it's a maximum turning point. When like this, it's a minimum. So this is the condition. Just understand the properties, all right? So we are given 5.11, 5.1, write down the coordinates of what? Of B on 5.1. The coordinates of B, which we said B is the turning point. And from our understanding, from this turning point concept, it follows that the point B is simply going to be given from the format that we are given. So there, as we can see, if it is x minus p, we are going to have p as the x value for the turning point. Take note. So we've got x minus 2. So our x is going to be given as what? As a positive 2. It's going to change the sign. Or you just equate that bracket of x minus 2 to 0. So x will be what? X will be 2. So at the turning point, x is 2. As we can see, the q is not affected, this q. Positive, here it's positive. So the value of y here is not affected. You take as it is, all right? So this is the concept. We have got our turning point, which is at what? At a B. So it simply tells us that the x value along this line, because that is our line of symmetry, it is what? The value of x, which is what? The value of x, which is 2 throughout this line, okay? Anyways, let us see. 5.2, write down the equation of the axis of symmetry. It is the one that I've already answered here. X is equal to 2 for this line. So this one is direct. 5.2, our answer was going to be what? X is equal to 2 for the axis of what? Line of symmetry at the turning point. All right. Then considering 5.3, determine the coordinates of what? A and C. All right. For 3 marks. A and C. A and C being the x-intercepts. These are our x-intercepts, remember? So in order for us to determine this, we are simply going to use the x-intercept concept. All right, the x-intercept concept in order for us to have A and what? A and C. For the x-intercept, we do understand that y is supposed to be what? Y is supposed to be equal to 0. So therefore, taking our f of x, equating it to 0, it means this whole part minus into x minus 2 squared plus 1 must be equal to what? To 0. It's an equation. You have formed an equation that you must solve for what? For x. With the understanding of our equations, we've got a quadratic here. Yes, you can choose to expand the brackets. It is up to you. Or you can simply take the positive one to the other side of the equation. So there is going to be a negative, or simply subtract it. So this is going to be what? Negative 1. As I have got a negative and a negative here, I can simply divide by what? By the negative 1, so that this can what? Can cancel. So I'm just left with the bracket of x minus 2 squared, which is equal to 1. Remember, in our grade 11 mathematics, we had such types of equations where we've got a bracket that is being squared, where we can get rid of the square. Instead of us expanding the brackets, we can simply introduce the square root both sides of the equation. Simply have to introduce the square root. The square root and the square cancels, and you'll be left with what? X minus 2. And that must be equal to the square root of 1. Square root of any number, plus or minus, for the square root of any number that you have. So meaning to say, we are going to obtain plus or minus what? Plus or minus 1 from the square root of the value that we are given. So thus, we can solve for x. Taking the minus 2 to the other side of the equation, we are going to have x is equal to 2. But remember, there is a plus or minus. So the minus 2 changed to positive 2 the moment it crosses the equal sign. But there is a plus or minus already on the right hand side. So do not forget that. So we can separate the sign which is affecting this one. There is a plus, there is a minus. So it's 2 plus what? Plus 1. Or we can have our x being equal to 2 minus 1. There are two signs that we have. So we're going to separate plus and a what? Plus and a minus. So thus we are going to obtain the possible x values from that. So x can be equal to what? 2 plus 1, which is 3, or our x is going to be 2 minus 1, which is 1. So this is what we're going to have as the x-intercepts, where y is equal to what? Y is equal to 0. In that case, we can finalize our points, because we know that y is equal to 0 for both conditions that we have. So which one is representing A, which one will be our C? So as we can see, A is closer to the what? Closer to the origin. So that can be our 1, and our C is the one that is going to be a 3, the one that is far from what? From the origin. So thus the point A will be given as what? So therefore the point A, the x value is what? Is 1, and the y value is what? Is a 0 for the x-intercept. And the point C, all right, this is A and what? A and C. So the point C, where the x value will be what? Will be 3, and the y value is what? Is 0. So remember, that is the condition for your x-intercepts. We have the points from the information that you're given. So it depends on the question. Answer as many questions as possible so that you can understand the idea, the brain of what? Of the examiner. What exactly do they think, these guys? The more we understand how they operate, how they think, the more we get prepared for the exam because we know their mindset. So let's do revise as many questions as possible. 5.4, for which value or values of x will f of x be less than or equal to 0? That's an inequality that we are given there on 5.4. Remember, when you are solving, okay, some of these values, you're going to need them later on. Remember, when you are solving inequalities, f of x is less than or equal to what? To 0. You are going to take your f of x minus 2 squared plus 1 is less than, right? This is what? Plus 1 is less than or equal to 0. Then you find the critical values. Then after that you check, all right, the graph is going to be affected with a negative. So the sign is going to be like this. Where are the critical? All right, guys. Are you going to do all that? No. Because already this is the function. And A and C, they represents the critical values, the solutions when we solve for this f of x being equal to 0. So already the critical values are there. You have the critical values already, the x value at A, which is 1, or we have got the x value which is at C, which represents what? Which represents 3. So as an inequality now, we must consider, because we have got also the function being drawn. So where is it that our f of x is less than or equal to 0? Remember, y is equal to 0 is what? The x-axis. So when we say less than or equal to, it is the condition when our graph is found below the x-axis. Below. So below the x-axis, it means we're talking about these values of x which are on this side and the values of x which are found on this side. So from 1 going this side, these values, they are less than 1. So therefore, we can say our x is less than 1. But remember, there is an equal to on our question. So we must also put that one on our solution. Or we are going to have our x being what? Values going this side, they are greater than what? They are greater than 3. But also equal to, because of that part of your question. So it must be greater than or equal to 3. So these are the x values that we expect. And these must be, these numbers should be real numbers that we are talking about. This is the condition. You see, your inequalities, they have played a role. So that is why I say, guys, that is why when I introduced also these inequalities in grade 11, I think we had that one in grade 11, check also the playlist. You will see everything, or the course for inequalities mathematics grade 11. Know all the ways of solving the inequalities. It's a graphical method, all right? So if it was a condition, they're saying that f of x is greater than or equal to 0. It is above the x-axis now. So when it is above, we are talking about this region in between, the one that is bounded by the graph. This will be your answer. Already you have that one on your graph. So learn also to use the information that you are given. All right, 5.5, determine the average gradient between what? A and B. Points A and B, the average gradient for 2 marks. So to have the average gradient, you just need points. Remember, average gradient as we are used, guys, as we are used to. All right, so this is 5.5. So we need the average gradient. All right, so we are given the points A and B. So from the points A and B, I can just write gradient of AB from the change in Y over the change in X. That's going to be Y2 minus Y1 over X2 minus X1, Y values over the X values. All right, so remember, We have got the point A, which is what? The point A is given as 1, 0. And the point B, which was our turning point. Remember, we stated this to the x value, which is 2, and the y value, which is what? Which was 1. This was the point 2, 1. Remember, we talked about this point before. So I can just name this x1, y1. This is my x2, y2. Point 1, point 2. So that is it. Let us determine our average gradient using the 2 points. With the formula that we have, we can simply substitute our values. So therefore, we are going to have this as what? Y2, that is 1 minus y1, which is a 0, over what? X2, that is a 2, minus our x1, which is 1. So that was going to give us a 1. All right, just using your calculator, guys, you are going to obtain a positive 1. So this is the condition. Moving on to 5.6, they are saying that the graph of gx is obtained by shifting the graph of what? Of f. Transformation of graphs. All right. So this one, I wanted to have it here so that we can properly see what is happening on 5.6. Remember that your f of x is given as what? Minus into x minus 2 squared plus 1. Originally, this is our function f of x. Now it is being transformed to gx. Gx is obtained by, what is it that we did? By shifting the graph of this one to obtain our gx. How was it done? All right, let's take the first one. 2 units to right. 2 units. All right, this is it. You've got your x-axis and your y-axis. The point, maybe it's here. The point, maybe it's here. Originally on what? On F. When it is now found on G, it has to move 2 units to the right. It has to shift 2 units. 1, 2. Then where it is now found in on what? On G. A transformation where we are moving 2 units to the right. How do you present that? Remember from our mathematics grade 9, this is the indication where we have got f of x minus a. It affects the x value, affects directly the x value. So the x must be in a bracket, f of x minus a. 2 units to the right. So the transformation is given as f of x minus what? Minus 2. It means 2 units to the right, minus. If it is f of x plus 2 like this one, it means 2 units to the left. When you solve for x, this is the idea, guys. You solve like this. X plus 2 is equal to 0. So x is equal to minus 2. So it means x is moving what? Negative units, negative 2 units, negative to the left. Are you seeing the idea? So when it is x minus 2, you say x minus 2 is equal to 0. So x is what? Positive 2. 2 units positive to the what? To the right. So the presentation for x opposes how you're understanding it. You're saying to the right, but you're putting a negative. That is the understanding for the x. This is whenever you're shifting along the x-axis. So to the right, it takes a negative, all right? So meaning to say, our gx must be equal to f of what? F of x minus 2 to show this shifting of 2 units to the right. This is what it means. Then they're saying, and there is also 1 unit downwards. How do you transform downwards? A function is now going down. A point is going down. A point maybe was here, then you are now finding your point, it has gone down. a translation, a shift, a units going downwards, it is given as f of x minus a. F of x, the original function as it is, you subtract the a representing the units going down. If you're going up, it's plus a. So in our case, they're saying we have 1 unit downwards. So that is f of x minus 1. On the original f of x that you had, you must subtract a 1. But we are no longer going back to that original f of x because remember there are what? 2 units that has been moved to the right. So on this one that we are seeing, which is our f of x minus 2, this is the one that we are dealing with. So this is our f of x minus 2 combined. We must subtract 1 on it. This is the idea. So it's f of x minus 2 as it is. Then we must subtract a 1 from this resultant. Subtract a 1 that is going down. This is now a translation going downwards. So guys, go through that video that I've made on the transformations, all right, so that you understand the meaning of each. F of x plus a, if it is minus f of x, everything. That is the way that you can easily attempt these questions, all right. So in our case, this is the transformation that happened. So it simply means our gx is equal to what? F of x minus 2, which means the translation which happened 2 units to the what? To the right. We are going to substitute in place of x. Remember, you're saying x minus 2. 2 units to the right. This one, in place of x, we must put that. So it's going to be minus. In place of x, we put this f of, input that. So that's x minus 2. All right. But already are we seeing that there is a minus 2 originally given. So you are supposed to subtract that. All right. Do not forget the minus 2, which was already part of your question. All right. Squared plus what? Plus 1 as it is. So guys, this here represents f of what? F of x minus 2. We have transformed our graph. But there is also a transformation which is left, this one. The shift of 1 unit going downwards, the minus 1. So on this whole part, let me indicate it this way. For this whole part, which represents our f of x minus 2, on this whole part that we have obtained, do not forget to transform the graph 1 unit going downwards. So we are supposed to subtract 1 from there. This is it. This is a combined transformation. That's a combined transformation. A translation of a units to the right and 1 unit downwards. So we can simplify this, okay, and obtain our gx. So meaning to say, here it is going to be minus 2 minus 2, that's minus 4. So you're going to have x minus 4 squared. Then 1 minus 1, that is going to give us what? A 0 there. So meaning to say we're just going to be left with our gx given as minus into x minus 4 squared, just like that. So we have obtained this part here. Write down the equation of gx and then sketch the graph of gx on the same set of axes. On the same set of the axes. Meaning to say, with our gx, this one, we are going back to our f of x. Remember, this was our f of x. So I'm just going to make a sketch here quickly. All right. Let us just have this one quickly here. Remember that the graph has shifted 2 units to the right and 1 unit down. And now it is given as what? As gx is equal to minus x minus 4 squared. All right. So this is the format of the turning point again. So it means our turning point, remember I said the x value changes. So there's nothing yet, there's 0 there for the y. So the x value changes to a positive and the y value remains as it is, as a 0. So that's our turning point for the new function that we are given. So its turning point is at 4, 0, as we have got 1, 2, 3, 4, 5, 6, and so on. Its turning point is here at what? At 4, 0. So it's like the turning point. Okay, we can even analyze here to see if this part does make sense or not. Okay, let's go back here. They said this is obtained by shifting 2 units to the right and 1 unit down. So it is 2 units to the right and 1 unit down. All right. So if we move the point B 2 units to the right, that's going to be 1, 2. So you're going to see that point here at 4 corresponding to what? To 1. Remember, this is 1. Then 1 unit going down. This is the 1 unit going down. It will end up at what? At 4, 0, which is exactly the transformation they have described there. 2 units to the right, then 1 unit going down. It will end up at 4, 0. Exactly the point that we have. So it means we are talking about a correct function there. All right. Anyways, are we seeing that the shape, guys, is not going to change? The shape is going to remain as this one because of the negative, as you can see, same formally. So the shape is going to remain as it is. But what is going to affect our graph this time? It is the y-intercept, as the shape is not going to change. And as this is your x-intercept, all right, we have got a graph like this, guys. Let's say your turning point is found on the x-axis. It means it is an x-intercept, guys. Remember, x-intercept found in the what? In the x-axis. So that condition, it means the turning point is also the x coordinate, which is the x-intercept. I mean, the x-intercept at the same time. It only has one solution for that turning point, which is your x-intercept. So if your graph is like this, it's going to go back. It turns at that point. If your graph is in the other way, it to that point, then turns back. This is the type of the graph that we are having, where the turning point is found on the what? On the x-axis. As the turning point is your x-intercept, it means that's your only solution that you have. That's the single root that you have. So therefore, our graph was going to simply maintain as the other one as it was. All right. So here, guys, it's just because of the opening part. I think my point 4, I did put it a little bit far. All right. But anyways, for the sake of sketch, this is your turning point, remember? So it must go back. So you guys, you can draw something better, guys. All right. Do not follow mine. You can have a better sketch. So it was going to be like this, where the y-intercept is now at a certain point from where we can even find the y-intercept by substituting the value of what? Of x, which is 0. So it's going to be minus 4 squared. So it's going to be minus what? 16. So the y-intercept will be at negative 16. So this is the graph of what? Of our gx. That is the condition. What was important? The location of the turning point and maybe the y-intercept if you want to indicate that one. All right. So draw your graph, a sketch. Yeah, I forgot your sketch. So you see how these questions are given as. They are very simple questions. Do as many questions as you can. You'll see that they are very, very simple questions. Do as many questions. Where you do not understand, the comment section is there. Let us communicate so that we can work on that specific section that we have referred to. So that is it, guys. Till we meet again.